Hey everybody, it's Mr. Carr again. Today's video, we're looking at 4.6 lesson. This is about the quadratic formula. This is it right here. The solutions of a quadratic equation, as long as we have a standard form that's equal to 0, okay, is given by the following formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you can also, if you like to do it this way, you can separate it as two fractions. So negative b over 2a plus or minus the square root of b squared minus 4ac also over 2a. When I do these problems, and I've seen students in the past, I think there's less mistakes that from this, okay? You can still do it as one big one, but you got to do it in the correct order. So in this formula, there's a special little section right here, b squared minus 4ac. That is what's called the discriminant. What the discriminant kind of tells us is how many solutions and what types of solutions we have. So for example, if b squared minus 4ac is greater than 0, which means we're taking the square root of a positive number, that means two real solutions exist. It also can tell us what type, because for example, let's say that b squared minus 4ac is a perfect square. Okay, I'll write that down here. Let's say b squared minus 4ac equals a perfect square. Okay, that means I have two rational solutions. But if b squared minus 4ac does not equal a perfect square, I still get two real solutions, but it's going to be two real irrational solutions. Okay, so that's just something to be aware of there. Again, this is only if it's greater than 0. If it equals a perfect square, those two solutions are rational. If it does not equal a perfect square, it is irrational. If it equals exactly 0, this is going to be only a one real solution system or solution. The reason for that is if we take the square root of 0, that just goes away. So my one answer is actually going to be this. It's going to be negative b over 2a. So if the discriminant equals 0, one solution exists, and the solution is negative b over 2a. If we have less than 0, we get two complex solutions, or unreal solutions. Okay, they're not real solutions if this is less than 0, which makes sense because then you're taking the square root of a negative. All that means is we're going to start using I as part of our solutions. Okay, so let's see this used in our setup. As I mentioned before in the formula, this only works if the equation is equal to 0. So we want to put it in that format. So in this case, I have x squared minus 8x minus 33 if I subtract that over, and that equals 0. We want to figure out what a, b, and c are. So a is 1, b is a negative 8, c is a negative 33. Okay, so we determine what the values of a, b, and c are. Now we're going to plug them into the formula. After that, we have to just simplify as best as we can. So for our purposes, we're going to keep them in exact form. So that means if there's a square root for an irrational, we're going to keep it as the square root in the answer. If it's a complex number, we're going to keep I in the answer. So x equals negative b, so it's going to be negative of negative 8, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So this is just a matter of working through my calculator. If you do this all in your calculator as one big step, great, do it. I'm going to show you step by step how it works, just so it's still, so you can see my steps on there. Make sure if you do it in your calculator, this tells me to do it twice. Go through with a positive and then go through again with a negative. So for my simplifying purposes, I've got the opposite of negative 8, so I'll turn into a positive 8. Inside, I've got negative 8 squared is a positive 64. Then I have a negative 4 times a negative 33. Well, and then times 1. So that comes out to, and so that's one thing I like to look at is that's a negative times a positive times a negative. That means it's going to turn into a positive in the end. If it was negative, positive, positive, then it'd stay a negative number in there. So this will turn into a positive 132 all over 2 times 1 is 2. Inside, I've got 64 plus the 132. So that's going to give me 196. So x is equal to 8 plus or minus the square root of 196, all divided by 2. Notice I am not doing anything with the division by 2 yet. This is going to be the last thing I do. Do not start dividing by 2. Make that like one of the last things you do. So I could take the square root of 196. I believe that's 14. Yep, 14. So this will turn into 8 plus or minus 14, all divided by 2. To get my two solutions, I can now split them up as two different answers. So the first one is going to be 8 plus 14 divided by 2. So that's going to give me 22 divided by 2, which is going to give me 11. The other solution is going to be 8 minus 14 divided by 2. So I do that, and I'm going to get negative 6 divided by 2 is a negative 3. So those are my two answers, a positive 11 and a negative 3. Okay, so here's one rational root that's going to pop up. Still want to do the quadratic formula. So x equals opposite of b. So, all right, sorry, it's equal to 0. Let's confirm that's a, b, and c. I'm going to use the separated version for this one, just so you can kind of see the difference. But it's still the same process overall. Okay, so x equals negative b, so it'll be negative 8 divided by 2 times 1. Plus or minus, we got b squared, so it'll be 8 squared minus 4 times 1 times 16, all over 2 times 1. So just doing this way, it's, in my opinion, a little bit nicer because then I can simplify negative 8 over 2. That's okay. And that keeps everything over here separated. So 8 squared is going to give me 64. Negative 4 times 1 times 16 is going to give me a negative 64, all over 2. Negative 8 divided by 2 is going to give me a negative 4 here. Then I'm going to have the square root of 0 over 2. Well, my answer, this is actually just going to go away. I get one rational solution, which is x equals negative 4. And that's it. So that's one nice thing when it's equal to 0 inside. So it makes it pretty quick and easy. All right, irrational roots. So this is where we're going to keep the radical sign as part of our answer. So again, that's a, b, and c. So x equals, and I'll do this as a combined one this time, negative b, so it'll be negative of negative 6, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Opposite of negative 6 is going to turn positive. I got negative 6 squared is a 36. Negative 4 times 1 times 2 is a negative 8 overall, so it'll be minus 8, all over 2. 6 plus or minus, that'll be 28 over 2. Now, to help with this problem, I'm going to do it very quick. Let's break down the square root of 28. So that is the same as 4 times 7, so I can square root that. This turns into 2 radical 7. So that means this is going to be the same as, I'll just rewrite it over here, 6 plus or minus 2 square root 7, all over 2. Okay, so for my exact form of this one, I can reduce it even further because you notice that 6, 2, and 2 are all divisible by 2. So that's what I'm allowed to do here. I can take that divided by 2 is going to give me 3. 2 divided by 2 is going to give me 1. The square root 7 does not, like, we don't do anything with inside the radical in that number. That will never, like, divide out at all. Okay. And then, sorry, that is just going to move down there because everything just divided out. If it helps to see it this way, it's the same as taking two fractions, 6 over 2 plus or minus 2 root 7 over 2. So 6 over 2 right here reduces to 3. These twos cancel to a 1, but we don't have to write it out. Root 7 just stays root 7. Remember, you cannot reduce numbers that are inside and outside. So it's the 2 divided by 2 that works. Okay, I believe this is going to be our last one. Yep, last example. Complex roots. Okay, like always, make it equal to 0. So 3x squared plus 5x plus 4 equal to 0. Here's A, B, and C. Okay. And I'll do this one separated. So I'll do opposite of B. So it's a -5 divided by 2 times A. Plus or minus, we got the square root of 5 squared minus 4 times A times C, all over 2 times A. All right. That's a clear. Okay. So that'll be a -5 over 6. Inside we'll have 25 minus we have 4 times 3 is let's say -4 times 3 is a -12 times 4 is a -48. All over 6 right there. Okay, so I got 25 minus the 48. That's going to give me a -23. So x equals -5 over 6 plus or minus the square root of -23 over 6. Now, we do not like to have this in here as a negative sign, so we're going to turn that into an I. So that, remember, it turns into this. It'll look like -5 over 6 plus or minus the square root of 23 over 6 I. So that's how I write it as a complex solution there. If I could break this down, like if it broke down like the previous example, go ahead and do that. Sometimes it'll come out to a perfect square. Maybe it was the square root of -25 in here. So if that was like a square root of -25, then I would have plus or minus 5i. Okay. But bottom line is those rules with our radicals stay the same, except we just have to add the I at the end. Okay. And that's it for our quadratic formula. So again, biggest thing I want you to choose for yourself, we'll come back right up there. You can either do it as one big formula, as long as you just don't divide by the 2a to the very end, or have them as two separate fractions, which I kind of prefer because I like the organization, but it's totally up to you. All right, that's it for today. Take care, everybody.